The number one lesson we took away when I was at Google is we should not use AI for the sake of AI. You need to have the exact answer, and it needs to be accurate and correct. Why don't we just let the agent do it? And then when I tried to run it, it just failed completely. The first thing I'm going to show everyone is a investment banking analyst agent. And it's also a story of when you should use AI and when you should not use AI for work on tasks. So my name is Jason, and I am a product manager. I used to work in ads attribution, which you don't know what it is, completely fine. It is a AI ML product. I used to do this both at Google and at Alibaba. And the number one lesson we took away when I was at Google is we should not use AI for the sake of AI. Back when we were first building ML applications, training a model was very expensive and it was very heavy and you need a lot of data. So we were very careful to say, hey, is this the right application? Is this the right place to use AI and ML? Or can we get away with using more traditional methods and then get just as good effectiveness out of it? Nowadays, it's so easy to call a LLM model, it's so easy to program something. I think a lot of people the first idea is like, well, why don't I just get an AI to do that? And I'll go through a demo or go through a demonstration of why sometimes that's great if it works, and sometimes why it just completely doesn't work. And we still have to use the old methods of writing code. So at a high level, what is LLMs good for and what are they not good for? LLMs, they're not good for if you just need one right answer. And I think in finance, this is a very important part because a lot of times financial decisions and or the data, you need to have the exact answer and it needs to be accurate and correct. What LLMs are really good for is if you need a variety of many possible answers, LLMs can go filter through that and give you all options on the breadth of data available. So what does that mean? Let me show you. So the example starts with, this is in the industry, we'll call this the Excel monkey, which I'm not sure who here has done or has people know who are from investment banking background. All right, one person. All right. Actually, so my friend he messaged me about this idea, and I was like, oh, I wonder how hard it is to do it. And then I tried it, and it's failed.
Well, beyond just generating trade ideas, even that aside, just if Claude can now sit inside of Excel and pull down a lot of information and actually help you build the models. So even if it's not generating ideas, just doing a lot of that time-intensive dumb work of pulling down data is useful. And then, of course, there's the next level, which is actually build a robust set of models. And if you can do that, forget about generating trade ideas, at least just make people's jobs easy.
Correct. So so if you didn't hear, basically a big part of the work on the average investment banking analyst is literally open these files from the SEC, look at the numbers, and then copy them into Excel, right? So this is what colloquially we call the Excel monkey. Every investment banking analyst does this, every investment bank does it. So if you don't know what they look like, this is kind of what it looks like. This is just a photo from the internet. It's lots of line items. The blue items are for where you punch in a real number from the findings, and then the black numbers are the numbers where you use a model or use a formula to generate. So this is what the output typically looks like. And so the idea was like, well, hey, this is something that's clearly highly repeatable. There's a process, there's definitely a correct answer and a wrong answer. Why don't we just let the agent do it? And that's exactly what I tried when Claude launched agents for financial services. And in their, and this is like no knock on Claude, but in their kind of press release, you can clearly see they had agents for building DCF models, you have agents for building LBO models, you have agents who were doing all these things that a investment banking analyst could do. So, and then when I tried to run it, it just failed completely. And I'll show you kind of a few examples of why it failed. Took this screenshot today just in case Claude updated the model. And it basically said, hey, why don't you just build me a restatement model for Apple over the last 3 years? And then basically it told me, oh, I failed to fetch the data from the SEC And then now I'm going to work through a complex response that takes over a minute as it tries to navigate through the SEC website and basically go find Apple. Right? And then, so it works. It tries really hard and keeps on doing that. And then basically it finally found the 10K. I was like, okay, great. I found the 10K. Now I'm going to try to open it and I'm going to read it. And this is what happens is because the 10K is such a large document, it basically ran out of tokens. And they ran out of tokens and say, well, here, let me try to figure out like, okay, maybe some parts I don't need. Maybe I have to go find the really important parts. So it keeps on trying to work through that 10K, and then basically it ran out of credits and basically ate through all my credits for one day just trying to process a 10K from the SEC. So I guess in ideal use cases, works great. But in practice, often doesn't work. So I had some extra credits, so I used a lot of a different account. And then I'm like, okay, well, here's the previous context. Please keep on working through it. It finally worked through it, and then it produced an Excel model for me. I'm like, okay, fantastic. I open it. I'm like, okay, top line, the revenue numbers all match. I go down here and like, what is this? Like, where did this number come from? Like where did this come from? They're like, oh, I found it somewhere. And then I open it and I'm like, oh, it doesn't come from anywhere. So, quick moral of the story. This is a classic case of extraction versus classification, meaning that when you ask the LM, say, hey, what is the cash position of the company? It's going to pick from one of these, and it's going to pick, and it thinks any of these is the correct answer, right? Because any of these could be the correct answer. It doesn't really care about it being 100% accurate. So LMs are really bad at extraction. It extract one answer. It doesn't extract the complete answer. And then so basically, this is a classic use case of, let's just use our little friend Python code. It's fast, it's deterministic, there's no token cost. It's going to work every time. But here's the other part where LLMs are really good, is if you say, hey, give me the revenue for this company. Well, different companies have different names for revenue. And this is where LLMs are really helpful because LLM knows all these things are actually different ways of saying the word revenue. So you give LLMs a list, you ask them, hey, please pick from this list. LLMs know exactly what to do. So in our demo, basically I'm using the LLM for matching things. It's also for recognizing that between a year. So for example, sometimes as companies evolve, they add new line businesses to their business, their SEC filing will change. So the LLM is very good at recognizing that, Amazon started a new business called AWS. And then so this is kind of the backend for this demo that I'm going to show you. Basically, we fetch from SEC, we parse the data, we try to build a tree or a data structure to be exact. And where we have problems, we use the LLM to troubleshoot that data structure. We have a verification engine that basically verifies it at the backend, and then we render it. So, and then I try this generalized process across a bunch of different industries. So far, so good. Very highly repeatable. We had one outlier that I don't know what happened, but I'm going to keep on troubleshooting it. So now I will give you a demo. All right, cool. So this demo, as you can see, fantastic. This is everybody's favorite screen. You just basically come here and company. I'm going to use Apple, and somebody else tells me to do a different company. So yeah, so it has a search. It goes to the SEC, fetches all the filings. Okay, all right. And then so now what it's doing is basically go and pull in the filings, and it generates the Excel sheet. That's how quick it was because it didn't find any errors for the pattern. So you can open the Excel sheet, and here it goes. So this is the bigger. So basically, what it found is it takes the most recent year and it shows you that okay, this is how the company classifies revenues, and then it goes back and it tries to match all the revenues going backwards, and it does that across all of the line items. So that's the income statement, it is the balance sheet, it is the cash flow statement, and very importantly, it does the financial checking and it makes sure that everything in the financial model is working the way it's supposed to. So if you have time, try it. It's sec-demo@mightwork.tech, and then you can just put in a ticker, and then you share it with your Gmail. Just click on share, and then it will share with you on your Gmail. SEC dash will be under sec-demo@mightwork.com. So, yeah. So in summary, basically, in summary, use AI for AI tasks, and then for other tasks where we have very good tools already, just use that for the job. And then, yeah, that's my demo. And then, yeah, any questions? Yes, please.
You just said the part where LLM will select the wrong cache because it's picked from three of the possibilities, right? However, if we try to change the temperature parameter to 0, then we guarantee to pick the most likely outcome.
Right. So I think that's a very excellent question where it picks the most likely outcome. But I think particularly for finance applications, I think that's a judgment. If you feel like
improves the accuracy.
Right. Exactly. Yeah. So I think that's the value judgment we have to make is like, do we find the most likely outcome to be a good outcome, or is it better to have what we call defense in depth, where we can try to use more rules-based systems to try to arrive at a state that we think more closely approximate the truth, and then use LLM like a final layer of verification / yeah. So, yes, please.
How does your tool account for restatements in prior years? So if there's like a 2023, let's say you're looking at 2023 report, and 2025, but the 2023 got restated slightly. Does your model flag that in any way, or how's that?
Yeah, so excellent question. It's about restatements, which very happen, and restatements is actually where the LM is actually useful. So how the model works is it parses through both the account names and the numbers, and it tries to match those two. And then where it detects that the account names match, but the numbers don't match, what it will do is it will make a secondary call to the actual parts of the notes to the consolidated statements to find out what happens. And if there is a restatement, it basically keeps the most recent finding, and then it stashes the difference into like a other column. So there could be other ways of doing it. It's just for this particular purpose, I just did it that way and just keep the balance sheet balanced.
So Jason, it was very quick when you were running the demo. Right? So there was no LLM involved when you are actually downloading and building the model.
Correct. So yeah. Why was there no LLM calling this particular one? The LLMs in this particular case is only activated if it detects what I call like a invariant. So what it means is it goes to the SEC website and it fetches all the data, right? And then it fetches all the data. It tries to construct a model deterministically first, and if it constructs a data model deterministically first, and it passes the validation criteria, then it skips the LLM, and then it just goes forward with that. You could add in a manual step or manual LLM step in there just to improve the accuracy, right? That's the thing. But I think for your application of choice, if you already has a set of rules that it needs to pass and it passes in the first run, up to you if you want to like insert an additional LLM step in there.
It's funny you said Claude could not do it. So there is this tool called endx. It means end Excel, right? And they sell a $400 a month tool. It fails equally spectacularly.
Oh, okay. Well, this is free for now until I run out of credits on my LLM account, so feel free to use it. Yes.
Just wanted to mention that what you said about the Claude Code for Finance was the initial experience, but this company is not stupid, and also they have big customers. What they did is exactly what you said. They reduce the temperature, they make it more deterministic, and now they build the reasoning to use as much as possible Python tools.
Right.
So right now, Cloud for Finance is working very fine, but they did exactly what you said, and they had to learn it on the fly and do it quickly.
Correct.
Sorry, what was that again? So, what tool?
Cloud for Finance.
It's Claude for finance.
Yes.
Yeah. So they just this
I think
is
they've open sourced the whole
yes.
repo for doing this.
Yeah, so there is they just launched it May 5th this week. So Quant Agent for Financial Services, and that's the tool I try to do this. Needs a little bit of fine tuning, but after that, it'll get you there. And I think I'm Alpine. Yeah. Alpine, right? Yeah. Okay. Great. Well, thank you so much for your time, and then if you guys, let's know. Let me know.